What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
With 0 meaning it's a natural object, like a comet, for sure. And 10 meaning it's definitely a technological object.
The space between stars just dropped another riddle. 3I/Atlas, the newest interstellar object to enter our solar system, was supposed to be just another cosmic snowball, a comet from another star drifting past the sun before vanishing forever. But as the data pours in, scientists are scratching their heads. Nothing about it adds up. Its motion, its chemistry, its shape, even the way it brightens and fades, all of it seems off. It's as if nature took the rulebook for comets and quietly rewrote half the pages. To understand why 3I/Atlas is so strange, you have to know what a normal comet looks like. Typical comets, the ones born in our own solar system, are ancient, icy leftovers from planet formation. They spend most of their lives frozen in the outer regions, until gravity nudges them closer to the sun. As they heat up, ices vaporize and form a glowing coma and tail. Their motion is predictable, simple gravity. Their chemical fingerprints, mostly water, carbon monoxide, and trace compounds, are familiar. They brighten gradually near the sun, fade as they leave, and never, ever accelerate on their own. 3I/Atlas, though, didn't read the memo. What follows is a countdown of the 9 anomalies scientists can't yet explain, the things that separate this cosmic visitor from every other comet we've seen. 9. The speed that defied expectation. When astronomers first tracked 3I/Atlas, its incoming velocity stunned them. Around 60 kilometers per second relative to the sun. That's nearly 40% faster than Borisov and over twice as fast as Oumuamua when it crossed Earth's orbit. Such speed means it's on a hyperbolic trajectory that can never be captured by our sun's gravity. The math says it came from nowhere near the galactic plane, possibly ejected from a dying star system millions of years ago. If that's natural, it suggests 3I/Atlas might have been flung out by a catastrophic event, maybe a gravitational slingshot around a gas giant, or even a binary star collision. But if it's not natural, the unnerving alternative is control, an object adjusting its own velocity across interstellar distances. No one's claiming that, but the numbers are strange enough to make even seasoned astronomers pause. 8. A brightening that shouldn't have happened. After passing behind the sun in late October, 3I/Atlas reappeared in early November, brighter than ever. That's not how normal comets behave. When comets go behind the sun, their volatile materials are usually cooked off, and they start to fade. But 3I/Atlas got stronger, like it had refueled during the blackout. The light curve data shows a sudden surge in brightness, far beyond what models predicted from solar heating alone. One possibility, it experienced a violent outburst, a kind of internal pressure release as volatile gases suddenly vented from beneath its surface. But that should also have altered its shape or spin dramatically, and so far, those changes aren't obvious. Another, more unsettling explanation. Something is actively controlling its orientation or releasing material in time bursts. The data isn't conclusive, but the anomaly stands. 7. The bizarre anti-tail. Early images showed a narrow tail pointing toward the sun, the opposite of what you'd expect. This anti-tail is rare but not impossible. It happens when the viewing geometry aligns just right, making the dust trail appear reversed. Still, the anti-tail of 3I/Atlas persisted far longer than models allow. It held steady for weeks before flipping into a standard tail. If it's natural, the explanation could be large dust particles ejected in a slow-moving sheet, which then curved under solar pressure. But if it's not, the symmetry and stability of the feature could suggest something far more organized, perhaps jets releasing material in precise, directional bursts. Astronomers noticed similar behavior in Oumuamua, which briefly displayed a narrow, asymmetric outflow. 6. Non-gravitational acceleration. The real head-turner. As 3I/Atlas approached perihelion, its closest point to the sun, it started accelerating in a way gravity alone couldn't explain. Observations from multiple telescopes detected small but measurable deviations in its trajectory. Natural explanations exist. Jets of gas escaping the surface could push it slightly, just like thrusters on a spacecraft. but the direction of the acceleration didn't fully match where those jets should have been pointing. Some scientists think the nucleus might be rotating unevenly, venting material in bursts that mimic propulsion. Others whisper that we might be seeing something that's not purely passive, an object reacting, not just being acted upon. For now, astronomers classify it as non-gravitational acceleration, a sterile term for something that shouldn't happen without an engine.
No, I think it's quite unusual. It's not like the comets or asteroids that we have seen from the solar system.
5. The giant nucleus. High-resolution infrared images from JWST suggest the core of 3I/Atlas is unusually large, possibly over a kilometer wide, much bigger than expected for an object this faint. That contradicts basic physics. Large comets tend to shine brighter because their surfaces reflect more sunlight. 3I/Atlas appears darker, like it's covered in a carbon-rich crust or non-reflective organic compounds. If it's natural, that surface could be the result of deep space radiation slowly baking the outer layers into a tar-like shell. But the near-perfect symmetry of its light curve suggests an evenly distributed surface, smoother than typical comets. The alternative? A structure that's been engineered or eroded into uniformity, not chaos. 4. The nickel-cyanide puzzle. Spectroscopic readings from the Very Large Telescope in Chile detected strange chemical ratios in 3I/Atlas's coma. The levels of nickel and cyanide were off the charts, far higher than in typical solar system comets. Nickel compounds usually form in high-temperature regions, while cyanides form in the coldest ones. Seeing both in abundance makes no sense. If it's natural, 3I/Atlas might have been born in a violent binary system where hot and cold materials mixed chaotically before being ejected. If it's not, that chemical cocktail looks suspiciously deliberate, like byproducts of fuel combustion or metal processing. Scientists are cautious, but the data remains unexplained. 3. The tail that refused to behave. Most comet tails flow smoothly away from the sun under solar radiation pressure. 3I/Atlas's tail twisted, split, and at one point seemed to fold back on itself. Time-lapse imagery revealed ripples moving along it like shockwaves. Natural explanations include variable solar wind or sudden jet outbursts reshaping the dust flow. But the patterns were almost rhythmic, repeating over several days, as if something on the nucleus was releasing bursts and cycles. Some researchers proposed it spinning rapidly, ejecting dust from fixed points. But the periodicity still seems too consistent to be random. 2. The perihelion temperature problem. At its closest approach to the sun, 3I/Atlas should have been cooking, surface temperatures exceeding 300 degrees Celsius. Yet its infrared spectrum barely changed. It didn't release water vapor in the quantities expected, even though it should have been boiling off rapidly. If it's natural, that means its crust is incredibly insulating, maybe composed of exotic carbon polymers hardened by cosmic radiation. But if it's not, that heat resistance could mean metal or ceramic material, not ice. It's one of the reasons some scientists have quietly compared it to Oumuamua's pancake shape, which also resisted heating in strange ways. 1. The origin nobody can trace. Perhaps the strangest thing of all, no one can tell where 3I/Atlas came from. Backtracking its path through the galaxy leads nowhere. It doesn't align with any known star system, cluster, or trajectory of ejected debris. It seems to have come from a void, a random direction with no obvious gravitational parent. If it's natural, maybe it was thrown out by a dying red dwarf billions of years ago, wandering the dark ever since. But if it's not, if it was sent rather than thrown, that would mean it's older than our civilization, maybe older than our planet itself. The anomalies pile up, and so far no single theory explains them all. Some scientists think 3I/Atlas might represent a whole new class of interstellar objects, something between a comet and an asteroid, built from ingredients we've never seen. Others suggest it's simply teaching us how limited our models are when dealing with materials forged under alien suns. But every time we get an answer, another question appears. Why did it brighten behind the sun? Why is its trajectory off? Why do its materials seem chemically impossible? Each discovery deepens the mystery. Oumuamua started this conversation years ago, Borisov continued it, and now 3I/Atlas is turning it into a trilogy of cosmic riddles. If the trend holds, each visitor gets stranger, faster, more unpredictable. Maybe they're random. Maybe they're messages, pieces of a galactic jigsaw we haven't learned to read.